Adjacent angles? When you hear the word adjacent, anybody know what comes to mind right off the bat? Probably. Next to, right? Next to. All right. Yeah, they are two angles that are next to, but they have to fit certain conditions. First condition, they got to have a common vertex. Have to have a common vertex. Next condition, they have to have a common side. And the third condition, which may be a little confusing, but I'll explain to you, they do not have any points in common. Okay? So look at letter A for me. I have angle X and angle Y, and we're going to determine if they're adjacent or not. So let's go through the checklist. Do they have a common vertex? Do they have a common side? Yeah, it's this ray right here. Now, here's what I mean by no points in common. Ready? If I put a point in angle Y, is it also an angle X? No. If I put a point in angle X, is it also an angle Y? No. That's what I mean by no common interior points. So these two are indeed adjacent. Okay, those are adjacent. They share a vertex, have a common side, and no interior points. All right, what about B? And if you're going to say no, be ready to back yourself up. What about B? Are X and Y adjacent? X and Y adjacent. What do you got, John? Done. They don't share a common vertex. Okay? So no, do not share a vertex. All right, now just it gets a little confusing here. Angle Y is this angle right here, everybody. Angle X is this angle right here. Okay, I'm not too sure why the circle's in there, but angle Y is this angle X is this angle. So here you go. Do they share a vertex? Yep. Do they have a common side? Is that point also in Y? Is that point also in X? So are they adjacent? Yes, yes, yes. All right, just if there's any confusion here, angle X is referring to this entire angle right here. All right, and angle Y is referring to this angle right here. Okay, so let's go down the list here. Do they share a common vertex? Yeah. Do they share a common side? Yes? No? I heard a couple no's in there. Yeah, this one right here, right? They share that side right here. Okay, ready? What's going to be the problem? It's in both, right? It's in Y and X. Cannot happen. So these are not adjacent. So no, they have interior points in common. All good? All right, nice job. Here we go then. Let's keep trucking. Okay, I'm going to get crazy on this one. Complementary. Your whole life, you're probably thinking angles that add to what? 90, and they do. But here's the thing. It can only be two. You can only have two angles that add to 90. Yes? That's fine. I'm sure my yelling catches up. Two angles that add to 90. Well, what if I have three angles that add to 90? You know what I call that? Three angles that add to 90. Complementary is strictly reserved for two angles that add to 90. Okay? Two angles only. So I'm sure back in the middle school days, you guys were used to maybe diagrams like this, 50 degrees, 40 degrees. Hey, I'm complementary, right? Those two angles. Well, now that we're here and in what class? Honors. Those diagrams aren't going to fly anymore. You're probably most likely going to see this. How do I know those two angles are complementary? And what's the box tell me from yesterday? It is a right angle. So I know those two angles have to add up to 90. Bonus question, honors kids. Not only are they complementary, they're also adjacent. Nice. Nice. All right, moving on. You have complementary, and then you also have supplementary, but now we add to 180. Again, same thing applies. It's got to be 2 and only 2. If it's 3, they're not supplementary. They just add to 180. All right. So again, middle school diagram. Oh, 120, and that's 60. Those are supplementary. Correct. All right. Honors geometry now. Those two are supplementary. Why? They form a straight line, and from yesterday, what's a straight line measure? 180, so I know those two angles add to 180, makes them supplementary. And they're also adjacent. All right. All right, I am already tired of saying they're adjacent and form a straight line. If they're adjacent and form a straight line, we have a new term for them now. Linear pairs. Linear pairs. The word linear has what word in it? Line. Yes, and ear, I know. Yep, good, good. Two angles that form a line, and they have to be adjacent to each other. Okay, two angles that form a line, and they have to be adjacent for linear pairs. 1 and 2. Yes or no, linear pairs? Why not? They don't form a line. Okay, so that's a big no spot. How about diagram B? Yes, they definitely do. Two angles that form a line, and then what about C? Well, first of all, they're not even adjacent. Why? They don't share a vertex, so I'm not even going to care about if they form a straight line or not. Okay, here we go. Your first exposure here. When you see the word theorem, you guys probably think Pythagorean theorem, right? Do we know what theorem actually is? What a theorem actually is? It is a fact that can be proven. Like the Pythagorean theorem, the fact is a squared plus b squared equals c squared, right? Well, you can prove that's true. Okay, you can, whether you want to or not, it can be proven true. That's what a theorem is. And in geometry, I know you're going to be so excited to hear this. During the course of the year, we're going to have about 50 to 75 theorems. Okay, about 50 to 75. And now you're not going to memorize. You're just going to use them so much, you're just going to know them. All right. Your first theorem of the year here involves linear pairs. A fact that is true about linear pairs. If you know two angles form a linear pair, what do I know about them? Okay, they're adjacent, but that's just kind of like a definition of them. That's not the fact I want. They are supplementary. Yes, that is the fact. If two angles are linear pairs, they are Oh boy, here we go right now. Huge mathematical pet peeve of mine. Have some self-respect and know how to spell these words. There is no I in the word supplementary. Have some self-respect. Don't be an embarrassment to the math community. All good? There is no I in the word supplementary. Now, the next question I usually get is, well, if I happen to spell it wrong on a test, will you mark it wrong? No, I won't, but I'll make some comments. Don't worry. Self-respect, all right, whatever. I'll put something down, all right? There's no I in the word supplementary. All right, so there's your first fact. Linear pairs are always supplementary. Questions on linear pairs? I want to keep using that. Don't tell me anymore they're adjacent and form a line. Use the darn term linear pairs now. All right, let's start talking big boy, big girl geometry. Vertical angles. I think they told me first period you've been exposed to this a little bit. Vertical angles. Some verts, as I call them. All right, the vertical angles. All right, first of all, Vertical angles, before I even get to those diagrams, are formed by two intersecting lines. You don't need to copy any of this down. When I do two intersecting lines, how many angles do I form? 4 of them, correct. Not those. How about these? The opposite ones are vertical. So 1N, 3 are vertical, 2N, 4 are vertical. But they have to be formed by intersecting lines. Okay? They just can't be opposite. All right? They have to be formed by two intersecting lines. With that being said, in letter A, are they vertical? Nope, but, oh, stop using adjacent. They are linear pairs, yes. Not vertical, but linear pairs, yes. Ooh, how about B? Ooh, oh. Are they formed by two intersecting lines? No, I don't care. They look opposite. Great, but they're not formed by intersecting lines. All right. And then how about C? Yeah, those are vertical. Okay, there's a theorem about vertical angles. But I'm not just going to straight up give it to you. You're going to find out yourself. Let's go back to my vertical angles here. Hopefully I don't make this math too hard for everybody. Let's say that's 100 degrees. What's this one next to it? Because they are linear pairs, and linear pairs are supplementary. See how we use these? If that's 80, what's the one next to it? And the last angle? You want to tell me the theorem about vertical angles? Vertical angles are, and don't you dare say the word equal. Thank you. Use the word we've been using, congruent. Another word that always gets misspelled. Believe it or not, you may not think so now. Ready? V-E-R-T-I-C, and then the wheels fall off. It is not L-E. It is not like the word barnacle. It is vertical, C-A-L, everybody. Vertical angles are congruent. Self-respect. Have some. Linear pairs and vertical angles, anything you want to ask? Because I'm going a little different direction with this next one, which is perpendicular lines. Perpendicular lines. Two lines that basically form a right angle. A triangle too? Sure. Okay. You have no idea that my two lines I just drew up here are perpendicular unless I put a right angle symbol, yes? Don't assume, never, never assume. Now they are perpendicular. Ooh, sensitive board. And you're not off the hook that easy. Here's line AB, here's line CD. I need to know if anybody knows the symbol for perpendicular because I am not writing the word perpendicular every single time I need it. So we know the symbol for line AB, here you go. And we know the symbol for line CD. Now I need the symbol for perpendicular because like I said, I don't want to write the word perpendicular every time. Anybody know? First period knew, there's a challenge too. Well, one person did anyway, out of 30. Anybody? Perpendicular? Dylan, think you got it? I know, I get you fired up doing it that way. Basically an upside down letter. Thank you. Perpendicular. Oh yeah, I remember that. No, you don't. Stop. I like that, yeah. They're like, oh yeah, like you know what's going on. You have no idea. All right, symbol for perpendicular. Minute 15. You and your partner, if you want to work with them or not. 1, 2, and 3. 1, 2, and 3. I'm not giving you too much time here. Let's go. Okay, give me an angle that is complementary to BOC. So BOC and the angle you give me, add to 90. Oh, suspense. Do we have a 26? I didn't think so. How about 11 we do? AOB. I like it. You could have also had, I don't know if anybody had DOE. That is also a correct one. Okay. All right, because if you're wondering, this forms a straight line right here, EOB, right? That's already a right angle, so these two have to add to 90 to get to 180, so that's another way. All right. What about supplementary to BOC? Supplementary to BOC, 24, do we have one? Nope, this is fun. 6, supplementary to BOC. EOC, everyone okay with EOC? Or COE, remember you could have it written the other way as long as O is in the middle. And how about adjacent and congruent to AOC? Not too bad, I didn't think. What do you got for me? 2. DOC, yep. Any issues with you guys there? Going. Basic, before we get into a couple word problems. I know your favorite. I got to read. All right, here we go. You guys have this next one. We took that one out this year. Here you go. 2 angles are complementary. Let's stop right there. What are we thinking? 2 angles, 90 degrees, right? Perfect. Degree measure of the smaller is 50 less than the degree. Ooh, nice. All right, so I have 2 angles that add to what? That's how I'm going to start this. 2 angles that add to 90. I just got to fill in the blanks with what I know about those angles. What do you know about them? Because, by the way, we don't guess and check in here. Not in an honors level course. Absolutely not. One is 50 less than the other. Well, I don't know anything about the other. Let's make it X. Okay, yeah, let's make it X. So there's the one angle. And what about the other angle? 50 less. X minus 50. Now, I'm sure some of you are wondering, and yes, we are doing a word problem. I have no idea what X means or X minus 50. What am I going to need off to the side here? Let statement. Yep. All right, so let X equal, what are we calling X here? Larger angle. And then X minus 50 would be the smaller angle. Yes. All right, now I don't know if the wheels are turning. Could I have called X the smaller angle? Yes, but then my larger angle would have been what instead? X plus 50 instead, so you could have went that way. All right, let's solve this beast. And we end up with X equal to 70. Again, you got to get in the habit of taking a breath after you finish a problem and solve for X, going back and rereading, what do I need to find? In this case, I'm asked for the larger angle. What did I call X? Okay, so I'm done. X is the value I needed. Questions, comments, concerns? You can, whatever floats your boat. Because it did say find the degree measure, so it's already assumed that's degrees, but you can. I'm not going to be picky about that. All right, next here. Come on. Whoa, calm down. There we go. 2 angles are? They add 2 then? Little different now. I don't think many of you are used to this. The two angles are in a ratio of 7 to 2. Here's what that means right now. All right, here's what that means. And you don't have to write this down, but here's what it means. That means one angle could be 7 degrees, the other could be 2 degrees. But I know that's incorrect. Why? Has to add up to 180. All right, let's keep going. Well, multiply by 2 now. One angle could be 14, the other could be 4 degrees. Is that going to work? No, right? Okay, what about now? Let's go 21 and 6. 21 and 6. Okay, this is ridiculous that we're doing this. I'm not going to keep multiplying by 7 and 2 all the time and see when they finally equal 180. We got to be able to do this algebraically. All right, because it's going to take forever, and 2 are in honors, and we're not guessing and checking. So basically, what am I doing here? I'm just multiplying 7 by a number and trying to find something that adds to 180, right? So instead of just putting 7 here, I can put 7 times what, right? That's what I'm looking for. Plus 2 times that same number, going to give me 180. Because that's what I did here. I did 7 times 1, 2 times 1. 7 times 2, 2 times 2. And then finally, I'll get that value of x that works. So anytime numbers are in a ratio, I'm just going to put x's with them. All right, plop them right next to it. So now this becomes, whoa. What's your 7x then? Let 7x equal larger angle, one angle, anything works here. And then 2x would be the smaller or the second angle, either one here. Okay, let's solve it. You got 9x equal 180. X equals the 20, but this is another case where you don't want to stop here because I'm looking for both angles. So what do I need to do with my 20? Take it in, substitute it back in. All right, so what's my larger angle? Because it says what? Find the degree measure of each angle. What's my larger angle? Buck 40. And how about the smaller angle? 40 degrees. And quick check. Are they supplementary? They add up to 180, absolutely. All right, so some word problems coming at you. You and your partner have the next. I have 7 through 12, you have 6 through 11, but same problem. All right, you got another minute 15 to get it done. Go ahead, and then we'll go over them. So, first angle, EBF. EBF, first angle, here you go, 29. 51 degrees. I'll go over anything you have a question with at the end here. EBA, we're looking at. EBA, what are we looking at? 7. 90. Pretty easy, right? It's a right angle. Here you go, DBE. Angle DBE, number 17, DBE. 17, groups 3 for 3 here. 3 for 3. How about 14 for DBC? 107, 4 for 4. How about ABF now? ABF, looking at 24 now. No. How about 25? No, we have one 25. No, we had a 23. How about 25? Great job again. How about 30? 141. 5 for 5. Don't ruin it. DBF, a lot of pressure here. 8, a lot of pressure. DBF. 68, coming through in the clutch. Anything else? Okay, you got one more. Okay, one more. This one, read the directions and mark your diagram before starting. Read the directions and mark your diagram before you start. Let's go, gentlemen, let's go. And then we should get 70 at the end. Okay, 70 at the end. Questions? Okay, again, the assignment's not much. It's just enough to get the job done and make sure you got a solid understanding. Because of the time, if you want to, what do we have? Oh, we have 6 minutes. You can get your Chromebooks out and start working. All right, that's plenty of time. Get a few done.